Chapter 12 begins. We've had a couple conversations off camera about it. Today, not terribly difficult here, just getting used to the number of the terminology things that we're going to use, how to understand certain types of pretty simple events here. So, sample space we'll talk about in a minute here, but where probability always begins is with the term an experiment. And this is, again, you understand what a science experiment is, where you'll mix some chemicals, or it doesn't even have to be chemicals. There's basically in your labs, you don't do a ton of them here. You will do a lot of them in ninth grade. I promise you that. Mrs. Melcher teaches all the freshmen. I know this to be true. But for math terms or for probability terms, an experiment is the performance of an action. Period, end of discussion. So we could talk about, we could find the probability of flipping a coin, such as I could get heads or I could get tails. It's really two things that could happen. The experiment would be when I flip the coin. And all things with probability, it deals with spinners and cards and dice and things like that, that all have unknown things that are going to happen. Like when you roll a dice or a die, six-sided die that you play with any board game there, you don't know what's going to come up when you roll it. You can get anything between a 1 through 6. You don't know. But the experiment is when you perform that action. The outcome is the result of the experiment. What happens? And these are terms, again, that we're going to use a lot this chapter, and I will use them a lot. So, basically, again, I could flip a coin. The experiment is me flipping the coin, and however it lands, whether it would be on heads or on tails, would be the outcome of the experiment, the outcome. Or if I had a spinner with, A, B, C, D in on it, when I spun the spinner around, and it'll stop on one of those 4 letters, whatever happens is the outcome. The sample space. All right. This is the collection of all the possible outcomes in an experiment. So stick with the coin one more time here. When you see sample spaces, again, I am not terribly bent out of shape about this, but they're put in the solution set brackets. So what are all the possible things that could happen if I flip a coin?
Heads or tails.
Right, I could get a heads or I could get a tails. So if I rolled a die, I could get the 1, 2, the 3, the 4, the 5, and the 6. So whatever all the possible things that could happen are, go inside sample space. All the different outcomes that could occur. All right. An event. Is a grouping of one or more outcomes from a sample space. So basically, the events, we'll come back to that here, when we talk about, basically I say an event could be, what's the probability of getting ahead? That would be the event that I would want to happen. I'm trying to figure out the probability of flipping ahead if I flip a coin. That would be the event. Detailing what you want to have happen. What if I flip the coin and roll the die at the same time? I could say, well, what's the probability of getting a tails and a 3? That would be my event there. The tails and the 3. So it's basically identifying a specific grouping, a favorable event that you want to occur. And again, we'll cover this a little more here. So, likelihoods of an event. I'm just going to put it like this. Make sure I spell it right. Hood of an event. And this is where it begins here. The first question says, tell whether the events are impossible, certain, equally likely, or not equally likely to occur. So there's four different things that could happen here. So first, an impossible event. Possible event cannot happen. Right? Has no chance of occurring. So if I'm rolling the dice here, and I say, what is the probability of me rolling a number greater than 7? Well, it's impossible. The normal 6-sided number die doesn't have it. It goes 1 through 6. There's no way I can roll a 7 or a number bigger than 7. It's impossible. It's not going to happen. There's a 0% chance that event's going to occur. Right? It's impossible. And there's no chance it's going to happen. Certain. I'll just put it this way. 0% chance. Certain. All right? Event must happen. 100% chance it will happen. 100% chance. So again, if I go back to the number die, and I would say, well, what's the probability of me rolling a number less than 7? Well, it's definitely going to happen because every single number on the cube is less than 7. 1, a 2, a 3, a 4, a 5, and a 6. Every single one of those numbers is less than 7. It is a certainty that I will roll a value less than 7. 3. Equally likely. Right. Events that are just as likely to happen as other events.
Like heads and tails.
Exactly. This would be 50%, or you could say a 50-50 chance. So, right, you can go back to the coin, and it said, well, what's the probability of me flipping tails? Well, it's just the same odds as me flipping a heads. Right? One of the two things is going to happen. Either I'm going to flip the heads or I'm going to flip the tails. The probability or the likelihood of either one of those events happening is identical. If I went to the number dice set here and said, well, what's the probability that I roll an even number? Well, that would be equally likely because there are 3 even numbers, 2, 4, and 6. But there's also 3 numbers that aren't even numbers, 1, 3, and 5. I got 3 numbers that are even, 3 numbers that are not even. There's 6 total things that are going to happen. And I'm going to get somewhere between 1 through 6. 3 of them are even, 3 of them are not. That is an equally likely happen event. All right? And finally, the fourth one, not equally likely. This is our last vocab term for today. One event will be more likely to occur. Not equally likely. So if I go back to my number die, and I said, well, what about the probability, or what is the likelihood of me rolling a 2? Well, there is a chance it could happen, but there's more of a chance I'm not going to roll a 2, because I only have one number that's a 2, and I have 5 numbers that aren't a 2. So basically I have a 1 in 6 chance of getting the 2, but I have a 5 in a 6 chance of not getting the 2. So the likelihood of me getting a 2 is not the same as the likelihood of me not getting the 2. I'm much more likely to not get a 2 than I am to get a 2. Right? Yeah. Very much so. So we're going to classify, and we'll look at number 1 here. We'll go through it. Yep, you can shift over to notes if you want here. And we'll look at number 1 here and talk about this one here. And you can do 2 on your own a little later. So number 1 is broken up into 4 parts, B, C, and D. And what it says is tell whether the events are the 4 things we just talked about. Are they impossible? Are they certain? Are they equally likely, or are they not equally likely? Literally, there's 3 things you're trying to figure out. Is there a 0% chance, a 100% chance, or a 50-50 chance of it? Anything else is not equally likely. Right? So what it says here is it's got 6 cards, numbered 1, 1, 3, 3, 3, and 4. And it's saying choosing a number less than 5. So, is that, here's my 6 cards, see them there? 1, 1, 3, 3, 3, and 4, right? So choosing a number less than 5, is that impossible, certain, equally likely, or not equally likely? Nash? Certain. Yeah, it is certain, because every single one of these numbers is less than 5. I'm certainly going to get a number less than 5. C, choosing a number less than 1. Nick? Impossible. Right, because every single one of these numbers are greater than 1. It is impossible. D, choosing an odd number or choosing an even number. Molly?
Not equally likely.
Not equally likely, correct. Because again, I have 5 odd numbers here. I only have 1 even number. The odds of those 2 things occurring are not the same at all. One of them has a much, much better chance of occurring than the other. I have a much, much better chance of choosing an odd number than I do choosing an even number. Not equally likely. Good with that? Okay. So let's talk about tree diagrams. So we're going to use them the rest of the way. And we're also going to talk about tables. But personally, I like the tree diagram method more. So we'll start, I'm going to build a few different examples up here. So first off, we're going to talk about, for a tree diagram to have any value, or a table, more than one thing has to occur. I can't draw a tree diagram with just flipping a coin. If I say, draw a tree diagram of flipping a coin, well, there's nothing really to diagram. It's just a heads or tails, right? What else is there to show? There's 2 things that could happen. But what if I said, draw a tree diagram showing me all the outcomes of flipping a coin and rolling a die. And unless otherwise stated, assume the die is just a normal 6-sided die or dice. Dice is plural. Usually you just say die, but just assume for all purposes here it's just a normal number cube, 1 through 6, that you play almost every single board game out there with. Okay? whatever reason we use a different type of die, then we'll specify that. But so now I could use a tree diagram here to kind of show me all the different things that could happen here if I flip a coin and roll a die. So I can still start with what I did up here, because if I flip a coin, there's two things that could happen, right? I could get the heads, or I could get the tails. But then I'm going to roll the number die as well. So what could happen when I roll the number die?
Zero. 1 through 6.
Right. So I could flip a heads, and then I could roll that number die, and I could get the 1, the 2, the 3, the 4, the 5, or the 6. Right? But I could also flip tails. And then what will happen when I roll the number die then? Right, same things are going to happen here. So this is a tree diagram. It's a visual representation that shows all the possible outcomes of an event. So if I said, how many total outcomes are there? How many different things could happen here? How do I interpret this? Well, what I need to do is count out my branches at the end. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 outcomes here. Now, if I represented this same information as a list or a table, which again, it represents the same thing. You can do it one or the other, but I could get the heads in the 1, I could get the heads in the 2, the heads in the 3, the heads in the 4, the heads in the 5, the heads in the 6, the tails in the 1, the tails in the 2, tails 3, tails 4, tails 5, tails 6. And notice again, there are 12 different outcomes here. There are 12 branches here, 12 different things written down in my little table or grid or whatever you want to call it there, list. But there's no event that I haven't covered. One of these 12 things will always happen if I flip a coin and roll a die. Right? What else could possibly happen that I haven't already listed out here? I could get a heads on a 4, a tails on a 2, and, you know, on and on it goes here. There's nothing I haven't covered. One of these 12 things is going to happen every time I flip a coin and roll a die. Right? So, why don't you try, I'm going to build one up here. You show me all the different outcomes. So let's say, I got this spinner here, A, B, C, and D. All right. And I'm going to say that and pick a card. 1, 2, or 3. So build a tree diagram or make a list, your choice, showing me all the possible outcomes that could occur. And I will walk around and see what you got there. Your choice. Tree diagram or the organized list. Your choice. But then write down how many outcomes there are as well. How many different outcomes. How many things could happen here with these events here. Spinning that spinner and pulling a card. When you're done, let me know.
Yeah.
Perfect. Yeah. Well done. Yep, perfect. Over here, over here. Yep. Got it.
got it.
Perfect. Yep, you bet. Yep, you got it. Perfect. Yep. Got it. That's good. Yes. Okay. Pics of, some people did the table, some did the tree diagram. But one thing I want to look at with the tree diagram now, we're going to cover this in more depth in a future lesson, independent versus dependent events. But we'll talk about it right now. Some people set up their tree diagrams this way. Like this, or some variation thereof. Other people, when I was walking around, set them up like this. And to all of you, I said, it looks good. There are 12 outcomes, by the way. So, both of these are perfectly fine to me because these are independent events. And again, we'll cover this in more depth, but the outcome or what happens with either one of these events has no bearing whatsoever on the other one. You agree with that? What I flip on the spinner, whether it's A, B, C, or D, has no impact whatsoever when I pick a card if it's going to be 1, 2, or 3. Right? One has nothing to do with the other. So, therefore, the order that I do the events doesn't matter either. What this is basically representing here is whatever you put first is the thing that you do first. In this case here, this how I would read this is you spin the spinner first and then pick the card. This one down here, though, you've picked the card first and then spun the spinner. Now, the order you do these two events doesn't really matter. Just like if I say flip a coin, roll a die, what you do first and second, it doesn't matter, right? I could go back to this here and I could rewrite it as 1, 2, 3, 4, 5, 6, heads, tails, heads, and so on and so forth. I could keep going, heads and tails, but I'd still have 12 total outcomes occur, right? Just like I could write, I wrote heads 1, I could write 1 heads, I could write 1 tails, I could write 2 heads, 2 tails, so on and so forth there. So the order that I represent this doesn't matter because one event has nothing to do with the other here. And that is true for everything in this lesson today, so you can interpret it however you wish. So, number 5. It says draw a tree diagram. Box has 2 shapes. You guys can try this one here. 1 triangle, 1 square. Without looking, pull a shape, then roll a number cube. So, try number 5. Same thing. It says draw a tree diagram, then count the number of possible outcomes. Same thing that you just did here. Box has 2 shapes, 1 triangle, 1 square. Without looking, pull a shape, then roll the number cube, 1 through 6 number cube. Huh? It's more of a coincidence here, but 4 and 6 aren't 12. So it's more a coincidence than anything, but anyway, I'll just assume I pull the shape out first, so what could happen?
Triangle
Yeah, so I'll just call them T and S. Triangle, square. And then roll the number cube. I could get the triangle, and then any of the 6 numbers could show on up here. Or I could get the square. And again, any of the 6 numbers could show up. I could certainly roll the number cube first, and then I could get the triangle of the square, the triangle of the square, the triangle, so on and so forth there with that. Same thing would occur there. How many outcomes are there?
12.
It's 12. Again, pretty much the same deal there. And I could have listed it, if you listed it with the table, that is fine. You could just go T1, T2, T3, S1, S2, so on and so forth there. If you want to list the table, that's fine too. All right, good so far? Okay. So let's move on here. Now, 7, we'll talk about this. It says make an organized list. But once again, you can, your choice. You can make a list, or if you want to do a tree diagram, do a tree diagram. Okay? I don't care. Do one or the other. Whatever you feel is more to your preference, go with it. Okay? Same thing with this one and this one. Do whatever you want. But now, think about this here. I'm going to give you another scenario. So let's say I want you to do this. Flip a coin. Okay. Roll a die. And spin the spinner. So I'll make another spinner real quick here. Assume everything's perfect. It's probably not the best spinner, but pretend it's all perfectly, everything's equal, A, B, and C, okay? Probably isn't. So if I said, make a table or a tree diagram for this one here, and I can walk through it if you're not sure. I'll give you a moment to start it. But what has changed between this one and the other one that we did? There's 3 things going on now, right? So, flip a coin. Let's start with that. So, what could happen when I flip a coin? I could get the heads, or I could get the tails, right? Rolling the die. What could happen there? All right, I could get the 1, the 2, the 3, the 4, the 5, or the 6, and ditto with this. So not much is changing right now at this point here, right? Kind of looks about the same. Okay, but now it says spin the spinner. So I could get the heads, I could roll the 1, but then I'm going to do the spinner. What could happen then? Right, so I can get the 1, I could get the A, the B, or the C. I could get the 2, a heads, a 2, and then the A, the B, or the C. I could get the heads and the 3, the A, the B, the C, 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 and same thing with tails over here. I could get 1, A, B, C, A, B, C, A, B, C, A, B, C, B, C, A, B, or C.
There's,
Now it gets a little crazy, doesn't it? A little crazy here. So now the question is, how many total outcomes are there? How do I figure that out? So what I need to do
24.
is I need to count out my final branches here. I don't count these branches right here. All right? I don't count these branches here. If I just flip the coin, and rolled the die, well, there'd be 12 outcomes. But what I need to do is count these branches up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then another 18 over here. 18 on this side, 18 on that side. How many different things could occur?
36.
There are 36 outcomes there. And again, I could list them all out. I could go H1A, H1B, H1C, H2A, H2B, H2C, all the way up through H6, and then I could do the same thing with tails. Tails 1 and an A, a tails 1 and a B, a tails 1 and a C, tails 2A, tails 2B, tails 2C, and on this goes here. So there would be, I assure you, I just don't want to write them all out. There would be 36 of them there. All right, so I do all the H3s, T3s, H4s, T4s, so on and so forth there. So this, again, emphasizing one more time, either or. Either generate a list like this or use your tree diagrams. You only do one or the other. No matter, I don't care what the directions say. Your choice. So why don't you guys try number 7?
On number 10, do we have to write them all? Or can we just write the number of outcomes?
List out the outcomes. There aren't really that many. Shouldn't take that long to do. But 7. So number 7 says flip a coin twice. Then roll a number cube 1 through 6. How many possible outcomes are there? So you can either make a table or a list, your choice. So the difference is we've done flip a coin, roll the number cube, but now we're flipping a coin, then we're going to flip the coin again, and then we're going to roll the number die. So 3 things going on here. Basically, if I write it out, you're flipping a coin, and then you're flipping a coin again.
Write it twice?
Right, because it's the same things that could occur both times you flip the coin there. But basically, this is what you're doing here. If I write it all out, you are doing 3 things. You're flipping a coin, then you're flipping the coin again, then you're rolling a die. So make a table, tree diagram, or a list, your choice. When you got it, let me know. Write down how many total outcomes there are. And I will come check it out. Flip a coin twice and roll a number.
I don't get it.
Got it? I like that, but it's because it's all one event. You represent 4 different events here. Even if it has page, right? Same thing. This is not a representation. This is actually 2 things occurring. You're doing 2 standalone events.
What are you doing this for?
You're basically running the experiment twice. I want you to run it once. Because you're representing this and then you're doing the same experiment again. But it's not do it twice, it's flip the coin twice, not run the experiment twice.
This one's like this,
Right,
that.
right. That's how it would work. So you got heads or tails, then I'm flipping the coin again. What's gonna happen after I flip heads or tails and flip the coin again?
Do you go for discover entity?
You could do that, I suppose. I could get a head 6 and then the heads or tails. All of those would have a heads or tails attached to them.
This should show that in
All things. And there's one coin, there's one in the die, and there's one.
Is that
second. Oh, I forgot to listen.
Heads, tails. This is just showing tails.
Yeah, but it could.
Okay, I see. So you're just calling me big ones or twos, it's second.
Yeah.
Okay. Unless there's no more. Yep. Right.
Is it 24?
Yes. We're representing two separate events here. So on your heads or tails, you should have another head or tails coming off it. That looks like it's just done. You shouldn't have, you're showing your rolling dice twice here. Here's one time, this is the second. Here, you're representing two different dice rolls there. And let's do, what are these EDC things?
Spin.
Let's just flip a coin, flip a coin, roll a die.
What?
The one that we're doing here, or is that the one that we did together?
Oh, maybe. Yeah, it is.
Okay. So, not too bad. But, again, you need to consider what's going on here. Make sure that we represent it right. So, again, I'm just going down the list here. It says flip a coin twice, then roll a number. So, first time I flip a coin, I'm just going to do it in order. I can get the heads or the tails, right? Then it says flip a coin twice. So next time I flip the coin, what could happen? First time I flip a coin, I'm going to get heads or tails. When I flip the coin the second time, what could happen? Once again, I could get a heads or a tails, or I could get a tails the first time. So basically, this is showing me what could all happen with my. If I flip a coin twice, how many different things could happen? 4. What are the 4 things that can happen?
Heads twice.
I could get heads,
Heads two.
I could get a heads and then a tails, I could get a tails and then a head, or I could get 2 tails. But one of these 4 things are going to happen every time I flip a coin twice, right? You'll get heads twice, tails twice, a heads first and then a tails, or a tails first and then a heads. That's it. And that's what I'm seeing here. 1, 2, 3, 4. 4 total outcomes, flipping a coin twice. So then it says, okay, so I flipped my coin twice. I could go heads, heads. I could go heads, tails, tails, heads, tails, tails. But then it says roll the dice. So I can get a heads and then a heads, and then I can get the 1, the 2, the 3, the 4, the 5, or the 6. Or I could get a heads and then a tails and get a 1, a 2, a 3, a 4, a 5, or a 6. Right? Or I can get a tails and then a heads and then a 1, 2, 3, 4, 5, 6. Or I get a tails and another tails, and then I could roll the number dice and I could get anything 1 through 6 there. So what am I representing here? If I count them all up, 24 outcomes. There's 24 things that could occur. If I list them all out, I get a heads, a 1, a heads, a 2, a heads, a 3, a heads, 4, heads, 5, heads, 6, heads, tails 1, heads, tails 2, heads, tails 3, heads, tails 4, heads, tails 5, heads, tails 6, or I get a tails, heads 1, tails, heads 2, tails, head 3, tails, head 4, tails, head 5, tails, head 6, or I can get the double tails, and then all 6 of those numbers could occur. There's all 24 outcomes listed out for us as well there too. There's nothing else that could occur. There's a lot of things that could happen if I flip a coin twice and roll a number die. 24 to be exact. But anything you could possibly imagine is somewhere inside this table here. So try one more here. How about this? Flip a coin 3 times. Flip a coin 3 times. What are all the things that, how many outcomes do I got here? I'm going to flip a coin, I'm going to flip the coin again, and then I'm going to flip the coin a 3rd time. What are all the things that could occur? Make me a tree diagram or a table, whatever you want. Shouldn't be that big, I promise you. Once you guys finish, then I'll pull a stick and you can tell me how many outcomes there are, huh? Not quite. Close, but you're only representing 2 outcomes there. Because you should have your heads or tails, and then the heads or tails, and then on side each of those second heads or tails, draw another branch from them. Okay, so how many total outcomes do we have? Kara?
12.
Nope. Diagrams here.
What?
So you would be here, and this is good there, but then the 3rd outcome should stem off. You're representing.
Is that right?
No.
What is wrong?
Right. Yeah. Right. Yep. That's good. So again, all you do is start with the beginning. First, I'm flipping a coin 1 time. That's all I'm doing, flipping a coin. I could get the heads, or I could get the tails. So there's the first coin. Now, flip the coin. What does it want me to do next? We'll flip the coin again. So I could have got the heads the first time. And then the second time I flip it, I could get a heads, or I could get a tails, or I could have got a tails the first time, and then the second time I could get a heads or a tail. So I've now flipped the coin twice. Heads, 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 tails, tails, heads, tails, tails. But now I'm flipping it 1 more time. So I could have got a heads and then a heads, and then when I flip it a 3rd time, I could get a heads or a tails. Or I could have gotten a heads and a tails, and then the 3rd time I flip it, I get a heads or a tails. I could get a tails and then a head, and then third time I flip it, I could get a heads or tails. I could get a tails and a tails, and then flip it the third time. I could get a tails or a tails. So if I interpret this here, again, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 outcomes here. What are they? And again, I can use my tree diagram to help me find them. Heads, 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 or heads, heads, tails, or heads, tails, heads, or heads, tails, tails, or tails, heads, heads, or tails, heads, tails, or tails, tails, heads, or tails, tails, tails. Here's all my outcomes right there. Think of any scenario with a coin that we haven't detailed out or articulated here. They're all there. Either heads or tails 3 times over in every possible order you can imagine. Number 9 should be pretty straightforward, I would think. Just doing 2 things. Again, you can make a tree diagram if you like, or you can make a table. Your choice. Well, number 8. I guess they do number 8 for you. So this one here says spin the spinner twice. How many outcomes are there? And then what are all the outcomes? So do number 11. When you do 10, you'll spin the spinner and pick a card. Number 11, spin the spinner twice. I would suggest making a tree diagram or a table, whatever you want here. You should do one or the other. But build the tree diagram or build the table to see how many total outcomes there are. That will let you see them all right in front of you with that tree diagram. So there's my spinner. I'm spinning it twice. How many outcomes are there? And then when it says the outcomes, you list them all out. The number of outcomes is how many you're listing. What are all the different things that could happen here? Huh? Pull it out here. How many outcomes are there? Hayden?
Wait, okay. Are we doing,
11.
Spin the spinner twice.
if you spin the spinner twice, you could get, X or Y, or X or Z,
How many outcomes are there?
9.
What are they?
I don't know, because I don't have it on my paper.
No? Make it happen. Hayden's working on 11. 13. It's right here. Number 13. Suppose you have cards of which has numbers 1 through 4 on it. 1, 2, 3, 4. You choose a card, put it back, choose a second card. Is it more, less, or equally likely to pull 2 numbers with a product of 4 or a sum of 4? Hint, make a tree diagram so you can see all the different outcomes out there. Are you working on it, Nash? You'll need to write. You will need to write. Make a tree diagram or a list. You need to see all the total outcomes to answer this question. Unless you have every outcome in front of you, you can't solve this. It's the only way you're possibly going to be able to. I'll pull a stick then.
Are all of them back in there?
I can put them all back. You'll see these types of questions again, I promise you. Your quiz is loaded with word problems, by the way, so get ready for them. It's not hard, but you gotta write it out. How many of you are even doing it? If you don't write out the tree diagram, not that you have no shot. It's the only way it's gonna happen for you. All right, Hayden, what are all the outcomes for 11?
Well, if you draw it twice, is it 8? Because then if you
Spin the
spin it
spinner twice.
you would get x and y hypothetically, and you would do x, m, x, a, x.
That's the cards. It says spin the spinner twice. The cards have absolutely nothing to do with anything.
Yeah, then you could get x or y. You could get x or z. You could get y or x.
So I would make a tree diagram, X, Y, Z.
Yeah.
And I can get X, Y, Z, X, Y, Z, X, Y, Z. So what are all my outcomes? I can get XX, XY, XZ. I can get YX, YY, YZ. I can get ZX, ZY, or ZZ. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's all 9 outcomes right there. And there they are all listed. All right, Max. 13. What did you get? Nora, you're on deck.
I got equally,
How do you know?
because you pull it twice and it's the equally same because adding before and
What are the outcomes that have a product of 4?
a product of 4.
Right.
Oh, 1 and 3, 2 and 2,
No, 2 and 2.
2 and 2.
2 and 2, okay. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So of these 16 possible outcomes, Max, which ones have a product of 4?
All of them?
What's a product of 4 mean?
2. There's only 2. A equals 4.
2
What does a product of 4 mean?
equals 4.
Something times something.
Nora, what does a product of 4 mean?
Something times something equals 4.
Right, so of all 16 of these, which of them, what times what equals 4?
4 and 1 and 2 and 2.
4 and 1, 2 and 2, what else?
No, then there's the 1 and 1.
4 and 1, 2 and 2.
1 and 4. I thought that's
Any others?
no.
Oh, so the products of 4 are 1, 4, 2, 2, 4, 1. Agreed?
Yep. And then there's
Now, Max, which of them have a sum? What does a sum of 4 mean?
They equal 4.
What does that mean?
2 plus 2, like something plus something equals 4.
Add. The answer to an addition problem. So what plus what equals 4?
2 plus 2,
2 and 2 plus 2.
1 plus 3,
1 plus 3.
3 plus 1.
and 1. So the sum.
1 plus 4, or no, not 1 plus
That
4.
1 plus 4 equals 5.
Yeah, I got that. 2 plus,
No.
That's it.
oh, what?
So my sum is 1 and 3, 2 and 2, 3 and 1, Now I can answer my question. Is it more, less, or equally likely to pull two numbers with a product of 4 or a sum of 4? Easton. More, less, or equally likely?
Equal.
How do you know?
Because
Because Nash told me.
Should be pretty easy to bring home here. Why is it equally likely? Why?
Because she's double.
Cord? Why is it equally likely? Yeah. Anybody, why is it equally likely? Huh? There's 3 outcomes that have a product of 4, and there's 3 outcomes that have a sum of 4. Since there's the same number of outcomes that total both, equally likely.